Okay, sorry about the break in video there, and we were almost done too. My computer got a little upset about something. So here we are, we're doing a Kirchhoff's voltage law to find the voltages in the unknown elements. So now we have voltages for 4 of our 5 elements, but we're still missing the voltage in element D. And there are a couple of ways that you can come by this. The sort of shortcut way is to notice that element D and E are in parallel. And when we saw that earlier, yes, we noticed that we had 2 elements in parallel, and we said that what happens for 2 elements in parallel is they have the same voltage. So that turns out to be true, and actually just to spell that out a little bit, I'll even write us a note. We'll get more into talking about series and parallel when we come in on Friday, but these are elements in parallel. They have the same voltage, but possibly different current. Conversely, when we have elements in series, they've got possibly different voltage, and really it's probably different voltage, but it's possible that our elements could possibly have the same voltage too. So I'll continue using the language of possibly different voltage, but these elements have the same current, right? And we saw that as we've sort of been doing our node analysis, is that if you look at our left-hand highlighted in yellow branch here, we have the same current going through that entire branch. And you know, if you really wanted to prove that to yourself, you could do a node analysis at this sort of bottom left-hand corner. And you would notice that if you had, for example, oops, I wrote that arrow the wrong way. Okay, so if you had, for example, an I coming in, if you had an I on this side, so we'll call it IC coming from the C direction, we'll call this IA going towards the A direction, you would notice in your node analysis that those things must be equal and opposite. So for elements in series, those elements have the same current. Anyways, so if you didn't make the observation that elements D and E are in fact in parallel, what you could do is a second voltage loop analysis around this interior loop, and that would be just as fine. And what you would find is, because elements A, B, and C are still the same, by necessity, element D would be that 10 volts. I'll go ahead and label that on here. So these are D, 10 volts. Okay, so now we've got voltages and currents for every one of our elements, and it's just about going through and multiplying everything together. All right. So starting with element A, we have 12 volts times 5 amps. And we get 60 watts. 60. And let's see, we said that element is supplying power. We found that out when we were doing our KVL up here, and we assumed it was a supply, and then we got a positive number. we had to, we assumed a direction, or we had already previously found the direction of current to know that that was the supply. And if you ever don't know that, you can return to this little diagram here and just make sure it matches. So if your element is going, if you're going sort of this way, your element is going from minus to plus in the direction that the current is also going in. You'll see that the power generated is a plus, and that means that you're supplying power. So what I'll say here is 60 watts supplied. By a similar logic, I'll go ahead and pause the video and sort of step through the rest of them, and maybe you can do the same and sort of follow along. Okay, so this is what I got. It's just a series of multiplication operations. And the last thing that I want to note before we close out here is that you'll notice that if you add up all the supplied power and you add up all the absorbed power, they equal the same thing, okay? And that gets at a principle called the conservation of power, which we'll see again and again around our circuits. And so if you get to the end of a circuit's problem where you're identifying where power is supplied and absorbed from, and that's not true, a little red flag should go off in the back of your mind that says, oh, something's not quite right here. And then you might have to go back and check an answer or something like that. But our analysis and our laws actually depend on that being true, depend upon the conservation of power. So that should always be true. Okay. Great. Well, again, thanks so much, everyone, for your flexibility with today's class. I really appreciate it. I'll be happy to take questions on this when we come back on Friday, or any questions that you might have over email. Or if you don't get to watching this till the weekend, that's okay too. And I'm always happy to hear your questions over email or in office hours next Tuesday. All right. Thanks so much. Bye.